Hi, I'm Julia Graham from The Naked Scientists. At the recent British Science Festival in Birmingham, there was a special event discussing earthquakes and how to forecast when they might occur in the future. I caught up with some of those involved to find out about their work. To kick things off, Roger Musson from the British Geological Survey told me about his work on earthquakes of the past and what messages they might hold for the future.
Well, obviously we can't use the same techniques as we use for modern seismology with earthquakes that are distant in the past. And in fact, modern instrumental monitoring of earthquakes really only begins in the 1960s. So to extend our knowledge of earthquakes really back in time, then the first thing that we need to look at is written sources that describe earthquakes that happened. And you can actually determine quite a lot of information about past earthquakes just through written descriptions that you might find in newspapers, in letters, in diaries. Because each account where somebody wrote, today I felt an earthquake and it was very strong and my house was shaken, we can make an assessment of the strength of shaking of an earthquake in any one place using something that we call intensity. And intensity works much like the Beaufort wind scale, which most people are familiar with, where you look at the strength of the wind in terms of what it's actually doing, whether branches are swaying or pieces of paper are blowing along the street. And you give that strength of blowing a number. And everybody knows you go up to gale force 10 and so on. Well, we do this for earthquake shaking. So if the windows are rattling, then we call that intensity 4. If small objects are falling off the bookshelf, then that's intensity 5. If you start getting slight damage, intensity 6, and so on. So by assessing intensities for all the different places where we have descriptions of the earthquake, we can build up a map that gives us a very good impression of the footprint of the earthquake on the countryside. And then we can compare that with modern earthquakes, for which we have similar intensity data, but which we also have instrumental recordings, so we know precisely what the magnitude was. And that enables us, by this process of comparison, to estimate what the magnitude of these past earthquakes were. And this gives us a very good basis for when it comes to trying to work out what the risk is of earthquakes happening in the future. And you can make simulations of what might happen in the next 50 years based on what's happened in the past.
That was Roger Musson from the British Geological Survey. Barry Parsons from the University of Oxford uses slightly more modern tools to make measurements of Earth movements from space. He explained how.
Okay. We do it using radars that are mounted on satellites. For instance, one satellite that we've been using is a satellite called ENVISAT, run by the European Space Agency. What the radars do is that they send a radar signal to the ground at a slight angle to the vertical, and that signal is scattered back to the satellite where recordings are made. We then come back to the same piece of ground and make the same radar measurement again, and we can compare those and the differences between them to tell us how the ground is moved.
So you bounce the radar wave off the surface of the ground and you're able to make measurements about the position of the ground relative to the radar. What can you use this information to tell us?
What we do is we use models of earthquakes. Earthquakes occur as a motion on a fault plane. And if we know where the fault plane is and how it's oriented inside the Earth and what slip occurred on it, we can calculate everywhere what happened at the Earth's surface. Of course, we don't know that to start with, so what we do is we make a guess, compare it with our observations, and then we change the parameters until we can get a model of the earthquake that fits our observations, and that we take to be what happened in the earthquake.
Are you able to use any of this information to help us predict any earthquakes?
The main purpose of the research is to understand what happens in earthquakes, but it does have implications for earthquake hazard. I think most people think that if you've had a very large earthquake in a place, then that place is safe from earthquakes for, say, 100, 200, 300 years, whatever the repeat time between earthquakes is, but certainly a long time. But the observations that we've made for the BAM earthquake and for the Haiti earthquake suggest that, in fact, there is actually quite a significant continuing hazard that needs to be taken into account when reconstruction efforts are made. In other words, for instance, if I talk about the Haiti earthquake, the fault that moved in the earthquake was not the part of the fault immediately south of Port-au-Prince. And the last motion on that segment of the fault was probably 250 years ago. So there is still another major earthquake waiting to happen in that area.
That was Barry Parsons from the University of Oxford. For residents of earthquake-prone areas, it would be invaluable to know ahead of time when an earthquake was likely to happen. To try and achieve this, scientists are using tools such as historical records and radar measurements, as well as experiments in the lab. Ian Main, from the University of Edinburgh, told me what stage they're at now.
Okay, well, there's been about 100 years of research into trying to predict earthquakes using precursors, that is, signs in the earth that an event is approaching. Precursory changes are very difficult to evaluate because they're always done after the fact. So what you do is you look at lots of data, or there are many studies done, and then the ones that get published are the ones which show a precursory signal. So there's a kind of selection bias in the process of finding those kind of anecdotal studies. And that's the main problem we have with precursors, is identifying these occurrences in real time. So we can find them if we look back into the past, but that assigns a false significance because we've selected those data.
So the benefit of hindsight is actually biasing what we find in science?
Yes, it's very important not to make too many inferences about predictability from looking at past records. Your model must be able to explain the past, but the only test of is it any use for prediction is if you make a forecast.
Do you think there's any hope for the future of being able to predict with any certainty that an earthquake is about to happen or likely to happen in the near future?
Okay, so this is the $100 question. But no, I don't think that's likely to occur in the next 5 to 10 years. And it's possible, from what we know about the physics, that might not be an attainable goal, given the fact that you would have to do detailed measurements, very, very near the fault in order to see the kinds of things that we see in the laboratory. You can never say something is impossible. It's impossible to prove a negative. But the likelihood is not great, let's say. But on the other hand, we can say a lot about predicting the risk or the hazard, and we can say quite a lot as well about, given the fact an earthquake has occurred, where the next place is likely to be.
That was Ian Main from the University of Edinburgh explaining that earthquake prediction might be a more difficult task than we may have hoped. I'm Julia Graham, and for more news and interviews, visit us online at thenakedscientist.com.